Okay, so today I am going to another discuss another problem. It is a GATE 2024 PYQ, and this problem is from electrostatics, and it's actually a very famous problem in the sense that many people actually share this problem in WhatsApp groups and try to know the answer, the concept. Actually, many students have difficulties in understanding the right concept of solving this kind of problem. So I will do this solution and make you understand that what should be the right concept to solve this problem, and also give an exercise problem to you. That is also an gate PIQ and based on the same type of concept. Okay, so first pause the video and give this a try by yourself. If you already know, that's good, and then look at the solution. Okay, so they mentioned the parallel plate capacitor with plane x at x is equal to 0 is grounded, and the plate x is equal to d is maintained at potential v naught. Okay, so the space between the two plates is filled with a linear dielectric, some permittivity, which is the x dependent, spatial dependence permittivity. Okay, so this is important. Okay, where epsilon naught is the permittivity of the free space, and neglecting the age effects. Age effects means that it is a finite. They are basically telling that it's a infinite. Don't bother about these ages. Okay, they are looking like infinite plates. Okay, so the electric field E inside the capacitor. Okay, so first try to draw what they are trying to tell. So they are telling there are two plates. The grounded plate is x is equal to 0. It is grounded, and there is a plane x is equal to d, which is maintained at potential v naught. Okay, and this separation is d. Okay, so surely there will be electric field in this direction from higher potential to lower potential. There is an electric field. Okay, so the first thing is, you know that del v minus del v del z. Suppose this is the z direction, or you can say this is the x direction. Okay, they are mentioning this as x, so this is the x direction. So del minus del v del x is equal to e. This is the fundamental thing. Okay, this is one of the fundamental thing. Okay, another fundamental thing which is the very important for this concept and the base of this problem. Okay, so if you have two mediums, say 1 and 2, with both at different dielectric constants, say k1 and k2 are their different dielectric constant, and suppose there is an electric field vector pointing in this direction making an angle theta 1, and there is another electric field E. There is suppose this is E1 and theta 1, this is E2 and theta 2. You know that the boundary conditions are D perpendicular should be continuous. This is continuous, and E parallel should be continuous. These two boundary conditions, you know. This is these two boundary conditions are the base of this problem. Okay, so D perpendicular is continuous means simply E1 K1 E1 cos theta 1 is equal to K2 E2 cos theta 2, and E1 sin theta 1 is equal to E2 sin theta 2. Okay, so this is the two things you know actually, and the same concept will be applied here. So this is the plate with filled with some dielectric from here to here. So you can imagine this plate is made up some infinitesimal thin layers. So this is dx, this is dx, small, very small dx layers, and they are filled. So in every layer, if e suppose this is e1, this is e2, let me zoom it a little bit. Suppose this is the infinite plate, and this is very small element dx, this is very small element dx, this is very small element dx, and this every x is changing, the permittivity is changing. So suppose at this point, at suppose this is a distance x and this is a point where your electric field is E1. At the next instant where the length is changed by dx, electric field will also change. Okay, the d is also changed. Okay, so the boundary condition will tell you that when going from this medium to this medium, your suppose this is k1 and this is k2, your k1 e1 is equal to k2 e2, right? So basically they are telling that D is continuous. That means if you are telling that E dot dx is V and D is continuous, means D is constant throughout the medium. So suppose this is also D, this is also D. In the next medium, suppose it is K3E3, but it is also D. So D is constant throughout the medium, and this E is perpendicular to the plane. So there is no component theta. So if you are calculating this E dot dx is equal to V, you can make this E as D by epsilon and pull this D outside of the integral, because D is constant throughout the medium. Okay, so this is the basic concept you should apply. So now let's try to do it. So E dot dx is equal to, suppose your 0 to D is equal to D delta V, and is 0 to V naught, it is simply V naught. Okay, so minus with a minus sign. Now pull out D outside of the integral, dx divided by 1 plus, now what is epsilon? Epsilon naught is equal to epsilon naught 1 plus x by D, 0 to D is equal to minus V naught. Okay, so you can now simply do the integral, that is it will give you log 2 with a d, I guess. So d is equal to epsilon naught v naught by d log 2, right? This is your d is constant, this value is constant throughout the medium. Okay, now what is e is simply d by, so e of x is simply d by epsilon of x. Now you know what is the value of d. So epsilon naught v naught d log 2 divided by epsilon naught into 1 plus x by d. So cancel epsilon naught. You will simply get v naught into x plus d. Sorry, yeah, x plus d into log 2. Yeah. So this is the answer. So the main concept is D is constant throughout any medium. The normal component of D, I should say, the normal component of D is constant throughout any medium. Now let's do the test problem. What I will give to you. So suppose this is a plate. This is suppose the separation is 1 centimeter, and in the middle of the plate, that means at zero point 0.5 there is a separation between these two mediums. It is a potential 10 volt, it is a potential 0 volt, and this medium has k1 is equal to 2, and this medium is k2 is equal to 4. Now suppose they are asking that what is the bound charge density at this boundary, at this separation boundary. Okay, so just do as I say. I mean, the concept will be same. D is continuous. Okay, and the next thing is E dot D is equal to V. These two things are the primary thing. Okay, so D is continuous, right? So suppose in this medium electric field is E1, in this medium electric field is E2. Suppose that means D is equal to 2E1 is equal to 4E2, right? So E1 is equal to 2E2. Simple. Now E dot D is equal to V. That means E into, suppose this separation is D, I will put D is equal to 0 0.5 at the end. So E1 into D plus E2 into D is equal to 10. Okay. Now E1 is equal to 2E2. So 3 into D is equal to 10. So E2 is equal to 10 by 3D. Right. So E1 is equal to 2E2, 3 into D is equal to 10. So E2 is equal to 10 by 3D. And that means E1 is equal to 20 by 3D. So you get E1 and E2. Now your job is not finished. You have to calculate the bound charge density. That means sigma bound. Sigma bound is what? What is sigma bound is E dot n. So it is your n cap, suppose, and P dot n, that means you have to calculate P1 and P2, right? That means you have to calculate, suppose, P dot n, that means P1 minus P2 dot n. Right? So what is your P2? P2 is equal to D2 minus epsilon naught E2, right? Now D2, that means D is constant. Okay, so D2 and D1 are same. So D minus epsilon naught E0. And what is D? D is your 2E1 is equal to 4E2. So let's make it 4. Sorry, I should make a epsilon naught 2 epsilon naught E2, 4 epsilon naught E2, because it is epsilon is equal to K epsilon naught. Okay. So 4 epsilon naught E2 minus epsilon naught E2, that is 3 epsilon naught E2. 3 epsilon naught E2. Okay. And E2 is equal to 10 by 3D. So epsilon naught 10 by D. And what is your P1? P1 is equal to 2 epsilon naught E1. D is 2 epsilon naught E1 minus epsilon naught E1. That is epsilon naught E1. That is 20 epsilon naught by 3D. So what is your now sigma B? Sigma B is simple. So 10 epsilon naught by D minus 20 epsilon naught by 3D. So 1 minus 2 by 3, 10 epsilon naught by 3D. Now put the values, you will get the answer. Okay. So it is probably 22,000 epsilon naught by 3. Okay. This is sigma B. So this is also an interesting problem. Okay. So the main thing that you have to careful, that this is a universal. This is this will going to happen in every time, in any situation. This will going to happen. There is no problem with this law. This will going to happen every time. D perpendicular is continuous. This will going to happen every time. Boundary condition, and another boundary condition is E parallel is continuous. This may also be useful for some case. So these three things should happen every time. So when you are facing some kind of boundary, there is plates, there are boundary, there is a continuous medium. Okay, there is a continuous medium with variable epsilon. Epsilon is variable with some function of x. You should keep these three things in mind. These are the most important things, and if you know how to apply these things, these problems will be better for you. Okay, so yeah, that's it for today, and thank you.